Hello, everybody. I imagine there are thousands of people online saying hello right now.
Oh, yeah.
I am Damien. This is
David Fowler.
David. We are back this year to do another talk together. I think we're convinced this is our last talk together.
Done. This is the last one.
We just don't want the stress anymore.
Get it now, and we're.
But you get to be in the room for the last. No, we'll probably end up doing more talks. But we are here to talk about SignalR again, because a lot of stuff has changed since we spoke to you last time. Who was at the talk last year? Who watched last year's talk on SignalR for ASP.NET Core? Okay, a lot of people. Good. Obviously, we were like pre-beta, like pre-preview, I think.
Preview
was super early.
Yeah, like alpha.
And now, as of yesterday, we have a release candidate, all right? It's part of ASP.NET Core 2.1. So that's what we're going to talk about mostly today, is all that greatness in there and a little look into the future as well as some other stuff going on. I will address the elephant in the room first. I have grown hair since I saw you all last. I actually could all along. I'm going to get you to grow your hair next.
Yes.
But we'll keep going. We're just going to start with a demo, because that's what we usually do.
All right.
So let's switch straight over. We're doing something new. We're actually showing David's going to do all the coding from his Mac.
Mostly because my Windows machine is pretty slow.
That's true. So
this is a bit faster.
You zoom it in a bit.
Can everyone see this? Is that a good font?
There we go.
Tell me when to stop. Good? OK.
So let's do Hello World. SignalR Hello World. What are we going to do this time?
So let's start from scratch. I'm going to make a new solution.
OK.
Bear with me a little bit, because this is VS Code.
OK.
.NET new solution. All right, we're done. Have a solution file. Okay. And now I'm going to do .NET new web-n will be demo1. It's restoring 2.1.
OK.
Almost done.
Almost done. Super fast.
Then I have to
It's good.
.NET solution add to add the part to the solution, demo1. And then open VS Code.
Who uses VS Code? Anyone actually use VS Code daily for .NET? Who uses it for .NET?
Oh,
wow. Okay. Quite a few. It's good.
Good. On Windows?
On Mac? Mac? OK, there we go. A lot of Mac users. Excellent. This is for you. This is all you folk.
All right. So in ASP.NET Core 2.1, we have this brand new template. It has a new package called the Microsoft ASP.NET Core app. I think Dan explained it in the previous talk. If you watched the previous talk, this is the new meta package, and there is no version. Because the version comes from
magic version.
Magical places. So
one less version to worry about is a good thing, though, right?
Yeah, exactly.
In the world of .NET Core, I think you can all agree. Anything we can do to remove versions is helping you, yes?
That's self-deprecating, man.
Good. All right.
So SignalR is included in this package, so I don't have to add anything. So I'll go to my startup class, and I will add to the services. VS Code is great. This works fine. Add SignalR.
OK.
And then I'll call app.use file server. Got ya.
File server.
Yeah.
OK.
I want to serve a static file from the
This is raw
root.
HTML.
No MVC.
OK.
Just raw HTML. I'll call use SignalR. And we have to add something here, some magic here.
So this is new, right? Like we're built on routing now.
In previous SignalR, we would discover all hubs in the application. In new SignalR, you have to actually map a specific URL to a specific hub.
Why did we make it harder?
Because it was more efficient, and it is better to be explicit than implicit.
OK.
You buy that? You should buy it.
OK. I'll trust you.
That's made it up.
MVC funds on my controllers for me.
Unfortunately.
Did you say unfortunately?
No, you didn't hear me say that. Is this live? Is this live? So let's call it
the architect of ASP.NET Core, everybody. So he's a little conflicted, as you might.
No, what? I'll create a hub called Application Hub, and I believe the namespace is demo1.
OK.
So
we're creating a hub. This is like the normal SignalR thing. This hasn't changed.
Well,
it's a hub, right? It's the same.
It's a hub.
And I'm going to put methods on it.
Derives from hub, has a different namespace. And now, that's my hub. I'm done.
OK.
Now I go into my startup class, and I call routes.maphub, passing in application hub.
OK. That's nice.
And I'll say the URL is app.
OK. So one URL, one hub.
Correct.
That's another difference from before. OK.
So now,
more explicit.
Yes.
Which is good.
This is good.
OK.
More code's better.
Good. OK.
I'll create an index HTML file, and VS Code doesn't give me any template, so I have to write everything from scratch. So
where's
HTML
where's your doc type?
There's no
Bang, bang. You need a bang. There you go. Capital, doc, all caps. All of them.
Is that right?
That means every single one. There you go. Space, HTML can be lowercase.
Really?
Yeah. In fact, it should be. Doesn't matter, but there you go. That looks better. There we go. Nice.
That was hard. All right, and now, so one thing we didn't show yet is that SignalR is decoupled from jQuery in the new SignalR core. Turns out if you remove jQuery, it's really hard to write DOM code. So to save time.
So all those people who asked us to remove jQuery just made it harder for everyone else.
So the last talk, we tried to prove a point by writing the chat without jQuery, but it turns out it's kind of sucky.
You want a framework.
So instead,
you want a framework, right? You want to use something.
Exactly.
Doing this raw is horrible.
So instead, I learned Vue like on the weekend.
Is Vue your favorite of all the options?
Yeah, of course.
Who uses Vue? Anyone use Vue.js in here to build their spas?
2 people.
Wow,
React?
7 people. React
Angular?
or Angular? Oh, wow.
Really?
Everyone uses Angular.
The new one? Okay.
Who would prefer the new one? Which new one?
Just 4. I don't know. It's like,
Isn't there a 6 now?
Yeah.
Isn't there a 6? Okay. I read Hacker News.
you know stuff. Okay.
Yeah.
That's good.
Who would prefer that we just did Blazor and then, okay.
Oh, burn.
I'll just write that down. Sorry, hang on.
All right.
Okay, good.
Let me see
Blazor.
if I can recall all my Vue expertise I learned on Saturday. So form.
Okay, just an aside. If you'd want to see something really funny, I wish we had recorded David and I sitting in a room last Friday teaching ourselves Vue.js. That was hilarious to watch, actually.
It was fun.
Painful is the word I would have used, actually.
It's pretty.
And I like it now. Like, learning anything
Super nice.
new is never particularly fun.
It's good because I don't have to explain it really. I can kind of gloss over the details, and
Yeah.
it looks kind of like you can understand it.
Yeah, you
know
can
what's
kind of
going on.
understand it as you go. All right.
I made a form. I did v on submit prevent, which prevents this form from being submitted on this button press.
You don't need
Whatever.
to
It
teach
doesn't
Vue.
matter.
Let's do SignalR.
Input type equals text.
Yeah.
Let's bind this to view model. Bind this to a type called new message.
Okay.
Let's do input type equals submit. Is that fine?
Yes, that's fine. Yeah, that's better, actually.
Because you told me
You
last
can
time
hit
it should be a
enter.
button.
You hit enter then, and you can use button type submit. That's fine.
No.
But don't go off script because it won't work.
Send. That's true. Let's call this add message. And then I need a fancy UI for chat, so let's make a UL and an LA and do v4
That's kind of nice. I must admit.
messages.
That's kind of nice.
Yeah.
That is a little better than the jQuery loop.
Razor is
reading
better.
HTML, I must admit. That's
And
elegant.
It is pretty nice.
Where's your IntelliSense? Moving on.
Good question. Who needs that?
No one. Not if you're a Spa developer.
All right, now SignalR. So I'm going to create a new hub connection.
Okay.
And in the RC1, we changed the API completely. So if you were using the older version of the older alphas, your code is now broken.
Okay. The docs are updated though, right?
They're updated, yeah. So I'm
In
gonna
seriousness,
create a
they
new-
are actually up to date.
Yes, yes.
Yep.
The day of, we updated it.
Cool.
Because we forgot.
Okay, so new SignalR connection of some sort.
SignalR dot
Okay.
hub connection builder.
Ooh.
It's a new builder pattern. It's very, very nice. With URL,
Okay.
what do I call it? App. And then let's build that. So now I have a connection.
Okay.
So now I have to do a couple of things. I'm going to create a view model, and I'm going to use ES6 because it looks awesome.
Okay.
It doesn't work in IE though, but I guess that's fine for now.
I what?
It works in Edge. It works in Edge,
Oh,
but not
okay.
IE, so it's
There you
okay.
go. Good.
So I'm going to create, because I want to use async to wait, I want to actually make the top level script be asynchronous. So
Okay.
I'm going to do this
Do an iffy?
super cool hack to make the top level method async. Oh, crash. By doing so,
Okay.
then making this async.
All right.
So now I can use this async to wait in here.
Nice.
All good. Perfect. So I'm going to create a new view model. Is it a view model or a view model?
I don't know actually.
Let's call it app. There's a new view. And I forgot something.
Give it an ID.
Supposed to be a div here.
Okay.
It's an ID called
The
app.
root of your app. That makes sense.
It's in my entire application.
Okay.
And the element is hash app. And then data. 2 things in data. Messages is an array.
Okay.
And new message.
Is what you're typing in, right?
Yep,
That's what
it's
you're
null.
going to send. Okay.
So the things that I'm declaring here are things that are declared as the model and as the message here.
Right.
So
Good
pretty
reference
basic so
already.
far. Now methods, I declared that I want to call a method called add message on submit. So I'm going to, in methods, add an add message method. And there's a new ES6 syntax that lets you define members of a class like this in line.
Of an object.
Of an object.
Yes. Nice.
It's kind of nice.
It is kind of nice.
So in here, I want to do connection. I want to use the connection that we got from SignalR and call invoke, send.
Okay, so we're calling the server.
Yep.
All right.
This dot new message, and
Pass in our message. Yep.
let's clear it out so the text box is empty.
So the UI updates. Yep.
Null, and then that's I think the view part.
Okay.
So now the last part is when data comes back in via SignalR, we want to update the messages array.
Right. So handle the incoming calls from the server now.
So connection.on, on send. Should probably call it on receive. Doesn't matter. Message comes in from the server. I'm going to get the reference to the actual view application, get messages from it, and then just push, because it's an array. I'll push this on there. And then I do, I'm missing a wait here. Await connection.start. And that should be the entire application if I didn't mess anything up.
Okay. You got 3 S's apparently. You got a bit S happy. In messages, maybe? In line 12 up where you reference it in your mod. There you go. Nice.
Pair programming, but like.
It's nice having people in the front row who aren't afraid
who just scream at you.
to call out, you got it wrong!
It's not terrifying at all. So this is good. I think this works. And the first try to work, right? Let's do it. So I'm going to go to the console and run .NET run. Boom. OK, into the right folder.
Okay, that'll do it.
.NET run.
Nice.
Give it a few seconds. We improved the performance of build and run a lot.
On modern laptops,
it was
not
much
yours.
worse.
Yeah.
What?
On modern laptops, not yours.
Might be right, actually. Zoom in to 300%. Is that good?
That looks good. OK.
Hi.
Totally failed.
Oh, one error.
Oh.
Didn't add method send on the server. So it's saying that it cannot invoke a thing that doesn't exist.
Oh.
Which is correct.
You added a hub, right?
Yeah.
Okay.
An empty hub.
An empty hub.
So let's fix that.
Missing methods. Let's go and add that.
So
you've actually got logging and everything.
We're demoing the logging in Sigler. It's
Nice.
first class. It's first class. Right? Works very well.
Actually, I mean, in all honesty, it actually did tell you what was wrong. It's kind of nice.
Specifically, yeah.
You got logging in the browser and you got logging on the server to tell you what was wrong.
So public task, send, string message, and this should return clients.all.send async. This got renamed from invoke to send for reasons. Trust us, it's fine. It's fine. And I'm going to call send and pass in message. So this broadcasts to all clients that are currently on this hub.
Right.
It calls this method on each client.
Right. This is basically SignalR 101 at this point.
Yep.
It's
Has anyone seen this?
5 years, 6 years.
This isn't new, right? To anyone that's
This is pretty basic, pretty straightforward, what we've always done.
So I should rerun this. I should use watch.
You should use watch.
No.
Watch is built in now.
It is.
So you should just use watch. Who went to Dan's talk, the previous talk? Anyone? Did he show .NET Watch Run is now built in?
Dan did it.
Can you show them that .NET Watch Run is now built in?
I can.
.NET Watch Run. What does that do? It watches your code.
It
and
watches
if the
the
code
run.
changes, it restarts the app for you. All right? Super useful if you're not using Visual Studio that's just for you in the background.
Convenient.
If you're using VS Code, then you need something to do that for you. So there you go.
Here we go again.
There we go. Nice. Nice. It took you 15 minutes.
Two
to do
windows.
basic
Wow.
That was good.
Awesome.
All right. Nice. All right. So we got the most basic thing in the world working. Nice. Now,
Oh yeah.
and using an actual JavaScript framework made it a lot more pleasant
Simple.
to watch,
Yeah,
I have to
simpler.
tell you, than it was last year when we did the same thing. So just a quick overview. SignalR in ASP.NET Core is very similar to what you know already. There are some changes. So it's the same hubs remote procedure call or RPC programming model that you're used to in SignalR. You get that server-to-client push capability. You can push to all users, or broadcast as we used to call it. You can push to groups. You can add and remove people from groups, and obviously you can push to individual connections as well. You can now stream results from your hub method using the new channel class, which is now part of the .NET Core FX, as they call it, part of the base class library. We now have a new JavaScript client written from the ground up in TypeScript, which you can consume as TS modules or JS modules or a UMD module if you're using raw JavaScript like you did here. Obviously, we have a .NET client as well. We have a documented protocol now for hubs with implementations in JSON and Messagepack. So this was a huge feature request from the original SignalR, which is, can I use SignalR but use a different protocol? I want binary because I want it to be faster and more efficient. We have that out of the box. We'll show that in a minute. We have, obviously, transports like we had before. WebSockets being the one that we want to use most of the time, but if you can't, fall back to server-side events for browsers to support it, and then all the way back to long polling over AJAX for those that don't even support the other two. And then we have integration with the new ASP.NET Core systems. We have integration with routing that we saw at the beginning there. Obviously, we use dependency injection, just like we use in things like MVC. And we also integrate with the authentication and authorization systems that are built into ASP.NET Core as well. And then lastly, we have a new scale-out system. We had scale-out in the original SignalR. It was one of the nice things about it. You have this turnkey scale-out solution that lets you scale out to multiple web servers. It did have some problems. It was really only optimized for one workload type. So if you had other types of apps, like chat, wasn't particularly good for chat in large scale, you had to do a custom scale-out, which was quite difficult. We have a completely new scale-out architecture, which we'll talk about a little bit, with a Redis implementation or the new Azure service that you may have heard about during the announcements this week. So changes from the original SignalR. No more jQuery dependency. We talked about that, which is great. You can use it if you want to, but we don't need it anymore. We don't do auto reconnect with that message buffering on the server anymore. That was incredibly, while it was useful, it was actually incredibly difficult to get right, very buggy, and caused a lot of restrictions with the overall architecture. So we've removed it for now. We might bring it back in the future, but as it is right now, most apps, from what we can tell, don't really need that. No more hub state. That was a feature very little people used anyway. No more multi-hub endpoints. So as you saw in the app there, you have to create a route, give us the name or the type of the hub, and then that URL will be used for that hub. We do have a prototype of hub multiplexing, which would enable you to bring that back. So if you had two hubs, you wanted to run them over one connection, you could. The protocol is that flexible now. It's just not in the box today. As I said, no more single model scale out. We have an easy ability to do custom scale out patterns now. And then lastly, we don't support that server ping pong scenario before. We now require you to have sticky sessions when you're scaling out. This is more typical of real-time frameworks. And again, it just makes things a lot easier and a lot less complexity has to be built into the SignalR framework in the back end, which means less bugs, hopefully more performance, more efficiency, all those type of things. So we don't have that anymore. Talking about performance, this is a slide I wanted to quickly share. So there are three groups here. Down the bottom, you can see it says WebSockets on the bottom left, SSE for service-end events in the middle, and then long polling on the right. This is a measure of latency. So we have the number of milliseconds on the left-hand side, starting at 0, going up to 600. And then each series is the number of connections. So whether we did the test with 10 connections, 100, 500, or 1,000. And then within each series, we have a cluster which is showing the 50th percentile, the 75th percentile, the 90th percentile, and the 99th percentile for this latency. So what do you take away from all that? WebSockets is obviously the most efficient and best performing in terms of latency transport that we have. That's what you really want to use. If you go to service-end events, you obviously get a little bit more overhead. You have to maintain 2 connections now. You have streaming happening over HTTP. We can't use binary protocols, so things are a little less flexible. And then long polling is the most heavy of all, and you can see that it scales the worst of all. When with 10 connections, they're all pretty much the same, right? But as soon as you start going to 100 or even 500 connections, you start having to use a lot more resources, and thus the latency goes up much higher when using things like service-end events and long polling. So we hope to make this better. Yeah. This is just what it is right now in the RC, but this is worth showing. We also have some other things we can show. So we do have if I move this over here, all right? So over here, I'll get my cursor to go over here. We can go aka.ms ms/ASP.NET/benchmarks. And it's not found because I typed it wrong.
Isn't it?
I did Asker. Ask MS. So this is a Power BI that anyone can look at. It's public, that tracks all of our continuous performance benchmarking that we do for ASP.NET Core. Part of that is we have a SignalR page. So if I come down here, let it load, and drop this up, we can get to SignalR. And then we have a whole bunch of pretty graphs. So this is showing different scenarios. I showed you a sort of echo scenario where the client talks to the server, waits for a response, and then sends another message as fast as it possibly can. This is the broadcast scenario. So this is where the server is trying to send messages as fast as it possibly can out to all clients without caring about who gets them or how quickly. All right? And then we aggregate, we count the total number of messages going through the system during these tests. So you can see here the difference between using a protocol like JSON versus a protocol like Messagepack. Messagepack is the dark color, JSON is the lighter green color. And so with WebSockets, we can see that we're getting better throughput and overall requests per second with Messagepack because the protocol is more efficient. Okay? You can also see it's a much lower latency over here, and it's using less memory in the process as well, and it's using less CPU. It's basically the best of all worlds, which is kind of what you want to get to, right? That is the point. Okay, let's go back to here.
Long polling?
We won't show long polling. Long polling is not interesting. All right, so let's go back to David, and David's going to dive in and add some more features
to this app. So I guess the first thing I want to show is the fact that SignalR also supports, well, this isn't new, but SignalR supports complex types in arguments and return types. So if my hub took in a complex type, it would get deserialized to that type and vice versa on the way out. So instead of a string, let's create an object called a chat message. Let's put it in models because I'm particular. It's called models. Let's create a type called chat message.cs. This is like super annoying, this thing. All right. Namespace, demo1, public class, chat message. It has a property. It's a string, not a static. Message. And then let's take this into the send method. I will send that message.message. All right. And this should work if I update the client to just pass in, instead of passing in this, it will pass in an object that has message equals, not equals, colon, new message.
So is this like model binding in MVC?
No.
It's not like model binding?
It's kind of like model binding, but it's not like model binding. Okay. It's less complex.
So it's a method with parameters, and it's taking stuff off the wire, and it's binding it
so SignalR
to my model.
Is straight RPC, so it will just deserialize whatever object you have on the wire as what you ask for in the client.
So it's not model binding.
It's not model binding.
But it's taking stuff off the wire and putting it in the parameters based on the types that I declare them with.
If you call it model binding, then it sounds like it's the same thing.
It does, doesn't it?
And it's similar, but it's not the same thing.
Okay.
It's like it, but it's not the exact same thing.
Okay.
Good?
Why is it not the same thing?
Model binding is pluggable and supports filling in things from other places, query string, form, arbitrary providers. This is like deserialized object.
Okay.
Doesn't work, you're dead.
Okay.
You're actually dead.
I'll trust you that that's a good reason.
The reason is the difference.
Model binding is tied to HTTP as well, as it is today, right? So
yes.
And as we'll show in a minute, SignalR is not tied to HTTP anymore. So there are reasons to make it different.
Good reasons.
You're not using .NET Watch? Oh, you are using .NET
I just
Watch.
turned it on again. This is all you.
Okay, good, good.
It's all lag.
Your muscle memory's wrong.
All right, so this works. Should still work.
Okay.
If I look at the browser network tab, which we didn't do yet, it should show this. Okay. This is super zoomed in.
It's a little too big. There we go.
Is that good?
Yep.
Right. So as usual, there's a negotiate payload. It has a request, a post request to the endpoint you specify for the hub /negotiate, and the response is a JSON payload that has your connection ID and available transport.
So that's how I started the transport. I said connect. Yeah. It creates a negotiate AJAX request, and I get a stuff back.
So if you don't support WebSockets, this wouldn't be here, for example.
Okay.
So unlike the older SignalR, this actually has in the protocol itself, the server has to respond with a message that says your transports on this server are these transports and these text formats.
This actually looks like it was designed.
Yeah, so we learned from the last SignalR, so this is actually a pretty interesting segue. The previous SignalR, to write a client, you had to kind of scrounge through our code and just reverse engineer it. And to be fair, there were a bunch of other clients that were written by the third parties that were actually like pretty good.
Yeah.
So we did a good job.
Okay.
But we did a better job in SignalR on ASP.NET Core because we have a specs folder. Specs. And there's 2 specs. There's one for the transport layer itself that explains if you're going to do HTTP, here's what you have to provide: a negotiate endpoint with the post. It tells you what the responses are. Transfer formats explains what that is. WebSockets explains what that is.
Nice.
Uses text like should and could. I'm kidding. It doesn't do that.
Written like a spec.
It is written like a spec.
Nice.
We're proud of that. And the hub protocol actually explains, for the two formats, JSON and Messagepack,
Okay.
what the payloads look like.
So for those inclined amongst
yeah,
those
if you want to write a client,
you can write a client
yes.
or a protocol implementation.
Or protocol, yeah.
Okay.
Or your own protocol implementation.
Someone could use Bond or
Yeah.
pick a different, I don't know,
Protobuf
Protobuf?
is the most common people ask for.
Okay.
Yeah.
Cool.
So,
All right, let's go. So can we change the protocol then?
all right, so
What are we using right now?
one interesting other thing, if I look at the WebSocket request and look at the frames,
Yeah.
the first thing sent is protocol JSON version 1.
Ah.
So the client says, I want JSON and I want version 1 of JSON.
Okay.
You have it server, and the server is like, cool, let's talk.
It's like Signal is all grown up.
It's like, I know.
It's actually like handshaking and
We learned some
thinking about
stuff.
the future and
We learned some
versioning.
stuff from last time.
We did learn a little bit from last
So let me try to add a Messagepack.
time. Okay.
Dun, 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 dun. So I
So
have to add some-
Messagepack, for those who don't know,
Is-
is
okay.
a binary
show that.
protocol. Where did it come from?
Some dude.
Some person?
Some dude wrote
Some
this
dude.
thing. I think a dude wrote it and during his PhD thesis,
Okay.
something like that. And
So all the best stuff comes from
it
someone who wrote it
apparently,
during their PhD.
it's like Bitcoin. Some dude wrote it, or somebody actually, or people, who knows actually. We
Okay.
don't know who it is. So it has support for every language, and it's a
my
very
goodness.
compact format,
Okay.
and it's pretty popular.
Is there a reason we chose Messagepack and not Protobuf to ship out of the box?
Protobuf requires schema, which makes it cumbersome to use. You have to define a protofile and code gen stuff. This is more like JSON.
Okay.
It's schemaless.
It's more loose.
It's more loose.
Okay.
Loose and compact. So
Okay.
it's best of both worlds for as default.
Okay.
So
So let's change to that.
let's change because I have all this stuff here. It's beautiful, beautiful. So does anyone here use npm for managing their JavaScript files?
npm.
I don't.
Get their client assets.
I don't.
He
I
doesn't.
just use CDN. CDN just deliver.
Everything you need is just on a website somewhere.
But you have to do it in the right order because dependencies.
Yes.
So
Okay, so what did you do there? You added
I added
Messagepack itself.
5, which is the library we use to
Okay.
actually do Messagepack. And then I added SignalR protocol Messagepack, which is the extension to plug in this protocol to JSON.
Do I
to
see
our-
Messagepack 5 is actually at version 4?
Yeah, the name is 5.
So it's not just us that has trouble with versioning.
It turns out it's pretty hard issue to solve in general.
Good. All right. Whew.
All right,
Okay.
so I did that.
So you
I
added
have
2
to
packages, basically.
Copy and paste this kind of long piece of thing that I'm not going to type because I don't want to type it.
Okay.
So I have the builder with URL. I'm going to add in this piece of magic sauce.
Okay.
With hub protocol, new SignalR protocols Messagepack dot.
Tell the
Messagepack
client
hub
to use
protocol.
Messagepack.
Yeah.
Okay. Fair enough.
So you create a protocol instance, and this shows that it's pluggable because this package is a completely separate thing
Right.
that can be pulled in and then overridden on the client.
Right. Okay. So now let's tell the server, I guess.
Yeah.
Yep.
Actually, let's run it and see what happens.
Oh, okay.
So you ran it.
I don't see any error. Oh, well.
It said
Oh.
error. Protocol isn't supported.
Wow.
So if you ask for a thing that isn't supported, it tells you on the server.
That's super helpful.
I know, right?
That's always JSON, I'm guessing. Like, we
Yes.
standardized on the handshake
The
thing,
first
JSON.
handshake is always
Okay.
JSON, so you know what format it is, because it's kind of how do
The
you
bootstrap,
how you
the-
negotiate the protocol if you
Sure.
don't know the protocol. So
And
you
it's
have to,
human readable, which is nice
Yeah.
too. Okay.
So let's on the server side, let's add the package to do. And look, it says on server as well. Fail to connection handshake.
All right. So you don't have to touch that window. That's just the logging.
So-
You're running watch.
Yeah,
Yeah.
I am running watch. You're
You
right.
don't have to kill
I
it.
saw you try to stop me from hitting
Don't kill
Control C.
it.
So I'm going to add a reference to the Messagepack library because it isn't in the box. And
Why is that one not in the box?
I'm not sure if Dan explained it, but Microsoft ASP.NET Core app is a new meta package that only contains first-party dependencies
Basically stuff we own.
and JSON.NET.
And JSON.NET, because it's kind of hard.
Right, James?
James is here. There he is. James is actually on the Signaler team now as well. So this is like doubly
So we
impressive for him.
can do whatever we want. Yeah, tell him.
You're in .app and you're in Signaler because you're on the team. So
I'm going to add Microsoft ASP.NET Core SignalR protocols dot Messagepack.
okay. And this depends on a non-Microsoft package, which is why it's not included. You have to
Yep.
add it in. Okay, fair enough.
Yeah, some dude wrote it.
some person in the community.
A good dude.
Okay.
So it's going to restore this package, or it won't
Unable
restore
to
it.
find a stable version of app. You broke it. Found
Okay, you
3
know
versions.
what? Hold on. I've seen this before. You just
Okay.
skip VS Code and you just use the command line. It works.
Oh, I see. Okay.
Yeah. All right.
Interesting.
Let's do this again. Yeah, there's reasons for that.
There's reasons?
I sent an email.
Okay.
It's a thing.
It's,
There's a bug somewhere.
as long as it's logged
Fun
and you
at
know
last.
the workaround, we can keep going.
Refresh. No error. What? Oh. Because we don't discover anything anymore because we want.
So you didn't configure it. You added the package.
Explicit code is always better, right?
Explicit code is always better.
Always. So I'm going to add Messagepack protocol.
Good.
Hit save. Wait till watch restarts the app.
Now, guys, the difference here, like just to point out, you told the client to use Messagepack.
Correct.
But this is configuring the server to support
support it.
Messagepack. It's different. Obviously, the server can still accept connections from people using JSON.
That's correct.
Okay.
So you can do multi-protocol depending on your client's capabilities.
So like you can have one hub, one app, and have
JSON.
some people using Messagepack
Yep.
over long polling. Well, maybe WebSockets. That's better because it does binary.
Yep.
And long polling JSON.
Yep.
And then later on, maybe even non-HTTP as well.
Which makes broadcast complicated, but we like
But
people.
we
so
make it work.
it's good. We make it work.
Nice. All right.
So that should be restarted now, and then it should say, if we did it correctly, all good.
Now it's binary and
frame,
it's opaque, we
opcode
can't
2,
see
look at that. So binary is great, but you can't look at it, so there's that.
It's hard to debug
So
because
hey,
it's just byte.
hey looks like opcode 2 mask.
Yeah.
But the length is smaller, so.
Can you get the value in there? Like when it says binary frame, can you like, does Chrome give you a way to like
What, the hex?
dump
Like, there's
the,
nothing. There's
the
just
bytes?
blah.
Yeah.
No,
No? Okay.
no. No.
Doesn't go, here's my memory.
There's nothing. We do have a thing called included in our logging for the client. I think we have a thing to log the actual content,
Okay.
but it just logs like hex.
Bytes.
So
Okay. Nice. Okay.
if you're looking at hex, it's pretty useful. If not, it's not very.
Anyone who's ever done networking with binary
Yeah.
protocols will appreciate how difficult it can be.
And this
But
3 every now and then that's appearing.
we
here
could
is-
build,
No.
total segue, we could build like a Wireshark plugin to view with our protocol,
actually
right?
true.
With our Messagepack Hub protocol to visualize. Someone from the community should build a Wireshark protocol viewer for SignalR.
We got set pull requests, but we don't want this one.
No, it wouldn't go in our repo.
Put it in a
but they should build it.
Contrib, yeah.
And then contribute it.
sounds good.
Is it still called Wireshark?
Yeah.
It's still called Wireshark.
It's still called Wireshark.
Okay, cool. All right, moving on.
So these 3s are actually,
Dude,
that's the backup mic.
that was the backup mic.
That's good. The 3s that are showing up here in the framing are pings from server to client.
Okay.
That's to keep the connection alive in case you're behind a proxy or behind a bad network. If you unplug your cable and
Okay.
you're offline.
Cool.
So keep sprinting that thing. All right. So what do we have next?
So how do I, so we've got a
Visualization.
hub, it's using thing, how do I push from a different place in my app? This is like the
yeah,
first
this
question
is one of the
people
things we
always
do.
ask.
Yeah.
It's like, I need to push from outside the hub.
Right.
All right, so let's do that.
So typical scenario is
Did you
like,
stop the app? So can I explain to you what Watch does again? So Watch,
muscle memory.
you don't have to worry about it.
Memory.
It'll just
I
monitor your
I
files.
just can't help it.
Okay.
I want to kill the server every time I'm using it. So I'm going to add MVC and add an MVC controller.
All right.
So the scenario is I want to expose my clients to be posted into a chat room from a REST endpoint, right? So I have to actually like expose something that can be posted to for any platform in any situation, but still publish to the SignalR clients. So I'm going to expose a REST endpoint by adding a controller in a controllers folder because you have to put it in there because this isn't C# and you can't just put it anywhere in the folder. You can, but it's nice to put it in here.
It's organized.
Message controller? Yeah.
Sure.
It's just controller. Namespace demo 1. Let's make this a new API controller. Did Dan show that as well? In his last talk, did he show the new API controller?
Yeah, you would have, right? Yeah.
Yeah.
Nice.
If you
like
didn't see
API
it,
controller.
it basically opts you into more conventions for API-specific workloads. Controller base. So now I have an API controller, and I'm going to add an endpoint called, let's do task, post message, and it will take in the same object, chat message, It's going to do something here. Do something.
Interesting.
To resolve this.
Okay.
Now, I want to actually get a handle on the hub context and then, like, say, broadcast to all clients.
So I can't just like new it up, obviously.
No.
Okay.
You cannot new up the hub and just like call it. That does not work at all.
Okay.
Don't do it. So in the past, we had a type called global host, which was a global static where you could get an instance to a hub context.
Right.
That's gone because in ASP.NET Core, we don't like statics. We like only DI. And
dependency injection.
And by default, we support into anywhere that can be activated by our DI container. You can just inject an iHub context.
Nice.
Of whatever your hub is. So our hub is called application hub. I can call it, hub context. And I have to declare private here. This is pretty cumbersome. I want C# to fix this for me.
You have the fix up thing. Doesn't that do that? You haven't tried?
I don't want to try VS
Okay.
Code.
Should be read only too.
You're that guy. That's what James in PR reviews. He says read only.
In VS, I just go Control dot.
He does. That's true.
Enter.
Does that work?
Does. Generates a field for you. Makes it private if you're in the constructor.
You win. Hub context.
I thought it worked in here too.
So now I have the hub context, and I'm going to do hub context dot clients dot all dot send async.
Right.
Send. And I'm going to pass in.
So now it's like you're in the hub. You can just call on it like you're the hub. Okay. And I'm assuming that you can send to groups. You can send to the.
Yep.
Okay.
So you could even add to groups from here if you have a connection.
Oh wow. Okay.
You can do clients dot all except clients, others, and just all the various
addressing
things of
Okay. All right. So let's.
Then we have this. Let's add a route to make sure that this can actually be hit from a browser.
Cool.
So I'm going to do HTTP post.
Okay.
And message.
Okay.
Perfect. And I didn't have to kill the middle at all.
So you're going to add some UI?
Yep. Let's add some UI to post now. So same chat style thingy, but instead, let's copy this here. And I want to add a header so I know what this is. This is REST API. And this is the hub API.
Okay.
And this should be add REST message, a new REST message. And it should be mostly copy pasta. So this, I guess.
Okay.
New REST message.
Okay.
And I'm going to add a method called add REST message. And I'm going to use the new fetch API in browser new version, not IE 6. So I can actually do has anyone ever tried to do a post with raw XHR just like in the browser without using it?
Without jQuery or anything else?
It is.
It's not fun.
Awful. So
yeah. Fetch is really nice though.
See if I remember the syntax. Fetch messages, and then I'm going to method is post.
Yep.
And body is JSON dot. Oh.
Is there any reason to your mixing of string literal terminators?
Oh, I did?
Just wondering.
Thank you, JSLint.
I thought you liked single quotes in your JavaScript.
I did, but then like JSLint kind of like
slapped you down? Okay.
And I feel bad. New REST message, and then I have to say content type is JSON because that's what it is. Content type is.
I am JSLint at this point. You realize that?
Oh, again.
Yeah.
Application JSON. That should be enough to post.
Okay.
All right, let's try this.
So now we have a different form. Type a message, you post it. It's going to go to the controller now, right?
Any bugs? Of course not.
No, it's fine.
Of course not.
And then the controller has a hub context, and then that's going to broadcast to all the SignalR people. That's a really big heading.
So JSON, is that H1?
You did an H1.
Oh, I should have made it H2.
Yeah, that'll fix everything.
Obviously. Oh, that's what it was. Whew. All right. So we're posting JSON in, and then broadcasting Messagepack out.
I'll believe you when it happens.
Test. No.
404. That's a routing issue, I believe.
Oh. Does anyone know?
Did you add MVC?
Oh my gosh.
Did you add MVC?
No.
So when you were saying explicit is better, Is this a demonstration of that?
I'm just trying to prove that we are pay-as-you-go, and I didn't pay.
That's a good point. We did talk about this as a core tenet of ASP.NET Core, is that you only get what you ask for.
On stage.
Being embarrassed in front of a live stream because you forgot to add
How did I miss that add in? No one even said stuff.
No.
Come on, guys. All right.
All right, now it's going to work.
Test.
Right? Look at that. Oh, not found. Look at that.
Did I call it message? Is that what it was?
Message. Post to message.
I think message is correct. This is wrong.
You said messages.
I know. Okay, third time.
Web programming is awesome.
Boom, but I can't refresh and just rerun.
There it is. Nice, okay.
All right.
That took a lot
Post from
longer
a
than I
hub.
would hope it would. All right,
Which is-
what else? So
We could skip to type.
we could
hubs.
skip a couple things. Like,
Yeah.
I think the most interesting thing might be the streaming. So I would
Streaming,
like
okay,
to
that's
see,
new.
we mentioned this new capability in SignalR is the ability to return streaming responses from a hub method.
Yep.
So let's have a look at that. What does that
All right,
mean?
so there's a new type in the BCL core effects in 2.1, and it also works in .NET Framework because it is net standard. It's a type called channel. Has anyone used Go channels or heard of Go channels or seen kind of Go channels? It's a producer-consumer API. So one side produces, one side consumes. It's a very simple back and forth API, and you'll see it here. So SignalR supports returning a channel from your hub method, and you can pump results back and forth from server to client, and we're going to add client to server in a
So
future
it sounds
release.
like a stream, but instead of sending bytes, I'm sending like
T's,
types.
any object.
Oh, any object I want.
Yeah.
Okay.
And it will get serialized over the same format that we serialize all the messages, so Messagepack or whatever.
Again, it's protocol agnostic. It just goes through the SignalR pipe.
Correct.
Okay.
So in my hub, I can add a method called count. It returns a channel reader of int, let's say.
Okay.
This is supposed to resolve.
So this is basically return a pipe through which I will send you numbers.
Correct.
Okay.
And I'll call it countdown. And this thing, I need to resolve it, is in the system threading, I can't zoom in here, system threading channels namespace. It's a brand new type
This is new in 2.1.
that we should blog about at some point.
We should. Is it in 2.1?
Where's emo? Yeah, it's in 2.1.
Okay.
So I'm going to take in a number from, and I'm going to count down to 0.
Okay.
From to 0.
Right.
So first thing I'm going to do is create a channel. So channel.create unbounded. So you can create a channel that has bound. And what that means is that if you go over the limit, if the consumer hasn't consumed enough, the producer will end up dropping packets.
I see.
Dropping items, right?
Okay.
So I'm going to create unbounded for now because
So it's like the size of the buffer, like whether the buffer internally
Correct.
is. Okay.
Yep. So I'm going to create an unbounded channel of integers, and I'm going to return channel.reader.
Okay.
So I'm saying whenever this thing returns, I'm going to just pump whatever is in the channel reader to the client. And then I'm going to do something super fancy that Damien was kind of confused by.
Yeah, I had to read this method a few times.
Let's create a method
This is a
called-
new C# feature.
So this is a local function. This is a function in a function.
It's a nested function.
The best part is like the code is after the return method, so it looks super wonky, but
No, it looks good. I mean, once you internalize it, it actually suits this use case very well, I think.
yeah,
But it's a little, like you said, wonky.
it's new.
When you first see it.
So I'm going to pass in a channel writer
Okay.
of int. I'm going to pass in the from, and I'm going to do, thing. So FORR, just in case no one knows, this is a reverse for loop, the most useful snippet
Oh,
ever.
wow.
Boom. So I go from thing down to 0.
Okay.
And I'm going to take the writer, and I'm going to write async I. I'm going to await that, because I should await things that are asynchronous.
Okay.
And now, I'm going to add a delay, so I don't write too fast. Delay 1 second.
Okay.
And then I'm going to complete the writer, and I'm done. Writer complete, which means I'm never going to write again.
That closes
That closes the channel
Channel's
completely.
gone. Okay.
And now I'm going to do something. I'm going to
Like,
call
kick it, right?
this method, and I'm going to
Go.
say channel.writer and pass in from. And this should be it. underscore means discard the result. So this is a feature in C# 7.1 called discards, and you can discard the result.
And it's like the underscore is special.
It's special.
Okay.
This means discard the result of whatever.
I acknowledge that this method is giving me something, but meh, I don't
Discard
care.
it. Yeah.
Okay. And it compiles away.
All right. So this is good. I think this works.
Okay.
I think
So
it
can we
works.
just hang on?
Let me. Yeah, you got it.
Create a channel. I pass the channel's writer and the start number to my private method, local function.
Local function.
Then I return the channel's reader to SignalR so that it can do its magic.
Yep.
And then the implementation of that thing is basically a loop that just counts down and pumps over the channel.
Right. So
Cool?
every call to write will stream a message back to the client side.
Okay.
And on the client.
How do I consume this from JavaScript?
Good question.
Okay.
Good question. Good question. So this is streaming.
So we're going to add a different form now to start a countdown.
And this is
Steam API. Are we announcing something we shouldn't be? There we go.
This is a number. This is a number.
Typos can get you into a lot of trouble in this industry.
This is kind of, yeah, actually, you're right.
All right.
Let's create countdown. Over here, let's copy this one because it's more similar. Let's create it last.
So now when I click on,
When I
type a number,
hit countdown,
hit countdown,
it should call
we'll call that hub method, passing in that number.
Pass in a number.
And then I'm going to get something back, I guess.
I have to parse the number, actually. This is
Oh, okay. Well, I mean, it's being explicit, which I know you're very fond of.
JSON works fine.
Yeah. No, but you like being explicit, right?
I guess.
Yeah.
Numbers.
Explicit is better.
No. Ooh. All right, so countdown is here. I'm going to call invoke countdown. I'm going to set number to no. And this should, oh, nope. I call stream. And this should return a stream.
Oh, okay.
This is new. And in here, I can call stream.subscribe, pass in, the syntax is super wonky, this. Pass in the next method. So whenever an item is streamed from server to client, next gets called with the actual data.
So I'm passing in an object that is a reader. That's what it looks like.
The object is basically a subscription callback.
Subscription callback. Okay.
Yeah.
With the next method on it.
Right.
Okay.
Correct. And it has next, on complete, and on error.
I see. That's why there's more than one. All right.
And I'm going to do app.messages.push item.
All right.
Yeah? All right. Magic.
Okay. I mean, doesn't work yet, so
Magic.
I'll saw the lady in half. There we go.
Ooh.
9, 7, 8. Well, I can't count backwards. 6, 5. 4, 3, 2, 1. Eric, so while that's streaming, because I've got one connection.
Yep.
And I called a hub method, and then it returned, and now the connection is like getting stuff.
Right.
Can I still use the connection for other methods while I'm getting stuff?
Let's make it 100.
Or did you take it over?
Let's make it 100. So it's 100, so it's a lot.
So it's
more.
counting down. Okay, so it's going to take a while, and I can keep like doing stuff. Like if we scroll down,
it interleaves.
Oh wow!
Streams and actual messages.
That's pretty cool. That's pretty cool. All right, so that's a new feature. And you're still using Messagepack?
Correct.
Okay, and you could change back and it would keep working, right?
Yep.
I trust you. All right.
You want to see it? No, it's fine.
No, let's not do that. No, okay. All right, I think we'll jump ahead, yeah? All right, that's pretty cool. So we obviously, just a quick recap, we saw routing, route to the hub. Parameter binding, we changed from a string to a strongly typed message.
Yep.
We showed you the new protocol support. You can use JSON or Messagepack. If you're so inclined, you can write your own protocol implementation. If you do, please tell us. Tweet us if you do that. We'd love to help you out. We showed you how to push from outside your hub, specifically from a controller. We didn't show you pushing from a background service, but we'll share that code. It's very similar. You get a hub context, but you get it into a different type.
Yep.
We have a new thing called an I-hosted service in ASP.NET Core, which is effectively a type that gets instantiated at the beginning of the application, and then it just runs forever, based on whatever code you write. And so you can do that from the background if you want to. Typed hubs, we kind of had a thing like that before, but instead of using strings to invoke the methods in the client, you can declare an interface and then just have the shape of the methods that way, so it's more strongly typed. And then obviously we support authorization just like you would in MVC. That's all just kind of like as you would think. You put an authorize attribute on the hub method and it just works. And then lastly, the streaming results from a hub method, which I really like. And obviously we have a .NET client, which just looks like what you wrote in JavaScript, but you write it in C#. So it's not really that different. Or F# or VB.
Or VB,
anything.
It's .NET.
So let's go a little bit deeper under the covers, all right? So we looked at features, but what about underneath here? Because there's a lot of new plumbing underneath SignalR, which is enabling a bunch of new features. While you're doing that, why don't you get the C# client ready so we can do the next demo that I'm preparing for. So what is under the hub? So in the original SignalR, this was the layer diagram. The hubs is what you write. You write a hub, and underneath that was a thing called a hub dispatcher. Hub dispatcher was an implementation of a thing called a persistent connection, which was kind of SignalR but without the methods, right? You just got a pipe and you would send messages back and forward, and that's what you would do. That plugged in to ASP.NET via a middleware, the persistent connection middleware. That was part of the Katana stack. Everyone remember Katana, right? That was this thing that we did on top of Owen. So Owen was how you plugged in this whole thing on top of some type of server. And then if you're running on system web, we had an HTTP handler that plugged into Owen, right? So that was your full stack that got SignalR running on top of ASP.NET in the existing world. With ASP.NET Core, the layering is a little different. You have your hub, and then underneath that thing, we have a hub connection handler. This is the thing that knows how to handle connections coming in on one side and then dispatch that off by parsing the hub protocol and then dispatching, finding the hub, creating the hub instance, finding the hub method to call, passing all those parameters in. That's all covered by hub connection handler. Underneath that, we have this dispatcher type, which is the thing that, given a HTTP connection running in ASP.NET Core, how do I turn that or dispatch that into the thing that the hub connection handler can understand? And then that all sits on top of routing. The same routing that MVC uses in ASP.NET Core, SignalR is using the exact same routing middleware. So at that point down now, it just looks like everything else in ASP.NET Core. So why do we have these layers? Why is it that we don't just stick hubs directly on top of routing, which is effectively what MVC does? MVC sits right on top of routing, but we don't do that in SignalR, and there's a reason why. And that's because SignalR, just like it used to be, is still server and transport agnostic. Now, old SignalR was tied to HTTP, so it wasn't really transport agnostic. All the transports, as we called them, that we supported, WebSockets, server-side events, long polling, forever frame, they were all HTTP based. You couldn't do non-HTTP with the existing SignalR. But that's not true with new SignalR. New SignalR doesn't care about HTTP, it cares about connections. So you have hub, hub connection handler, hub connection dispatcher. There's nothing about HTTP at the top of the stack, which is where SignalR lives. And then underneath that, you have the HTTP stuff before it hits Kestrel, which is our web server. Although, is it really a web server?
Oh.
Which is our server, which can then talk on top of different server-level transports, right? Sockets, system.net.sockets, which is new in 2.1, is now the default. Or libuv, which is what we supported with ASP.NET Core up until now. It still works, by the way. If you still need one of the libuv specific features, you can use it, but we've switched to sockets by default. But what if we want to run SignalR over something that's not HTTP, like directly over TCP? Well, the stack gets a little bit simpler because you don't have to dispatch through the ASP.NET Core middleware layer. We have a hub, we have a hub connection handler, and that plugs straight into Kestrel. So Kestrel has this new capability of, I deal with connections. Connections come into me. I am a server. I open a port, and then people connect to me. That's all it really cares about. Everything that happens after that all depends on how you configure Kestrel. What connection handler do you plug into Kestrel that speaks some type of other protocol at layer 4?
Layer 4.
4, thanks.
Right.
Yeah. Layer 4. HTTP is one of those, for example. But what if you want to do something else? Kestrel can speak anything if you write a connection handler for it. And then it's on top of sockets and libuv. So what would it look like to run SignalR, the same app, but have clients that aren't speaking HTTP?
Same app or a similar app? I have an app done already.
One you prepared earlier.
To save time.
Julia Childs. Nice. All right.
All right, so normally you'd wire up SignalR in the startup class. So this is your pipeline. You get configure services. You add a bunch of stuff to it. And you configure the HTTP pipeline right here.
Because you're in ASP.NET Core land. You're in HTTP land right now. Right.
So a connection in HTTP land is you start from a URL, and that URL is your connection binding information.
Okay.
Right. So chat is how you bind to an HTTP endpoint.
Okay.
For TCP, you're binding to a port and IP address. Okay. So if I go into my program CS, I have this new API that is added in SignalR. There are a bunch of overloads for various.
Sorry, you said this API was added in.
So the API was added in 2.1.
Okay.
To do this binding.
In Kestrel.
In Kestrel.
Okay.
So Kestrel,
So Kestrel can now just open up a port and say just bytes.
Yep.
And then you have to configure a handler for it.
Yeah, and if you don't configure a handler, it will use HTTP by default.
Oh, okay.
So this one is HTTP.
Yep.
This one is HTTPS.
Okay.
So HTTP. And this one is short circuiting and saying, I'm going to use the chat hub. So it's the same hub instance from a different transport.
So the same hub type.
Yeah, hub type.
Same
Yeah.
hub type, but we're using it from not ASP.NET Core
Yeah.
HTTP land, middleware land.
Yeah.
We're using it from Kestrel, like
Right.
into Kestrel like that.
And it's the exact same universe, because if you have clients from both TCP and from HTTP clients, they're in the same space.
But you're hanging off the same web host, so it's the same DI, it's the same
DI,
logging, it's the
same
same
logging.
configuration, it's
Right.
all the same universe. It's just that you've got Kestrel doing HTTP traffic
Right.
over here with middleware, and then Kestrel doing TCP
Right.
with what we call connection middleware. Okay.
So Sigler has no idea what the actual connection handler is under the covers. It just knows that it's getting bytes from the wire.
Okay.
Sockets, libv, WebSockets, service and events, long polling, they all abstract to that connection layer.
Okay.
So if I run this now, which I did run it somewhere today, here. I ran it and it says HTTP because we should fix that.
Oh.
But
it's not actually.
yeah, it's,
Okay.
it's three things, three ports. It's listening on 5000, 5001 HTTPS, and 8009, which is my TCP port running hubs.
Okay.
In this application, I also have a new sample called client app. I'm going to have this magic folder that isn't shipping yet, but it's a lot of code.
So we're going a little bit beyond what's in 2.1 right
Yeah.
now.
Yeah.
So we're showing it's possible with 2.1
You can do it,
bits,
but it's not all
you
in
have
the
to
box
write
yet.
more code.
Yeah.
And the plan is
To make it into 2.
we'll bake this in as we move forward a little bit more. Okay.
So my client app is my regular hub connection builder. This is the C# client for what you saw in JavaScript.
Okay.
I create a hub connection builder. I use logging that we have in ASP.NET Core. So this is the same logging you can plug in.
It's funny that it
Any of our
actually
providers.
doesn't look any different. Like,
Yeah.
it's hard to tell the difference between C# and JavaScript.
That was on
now,
purpose.
Sometimes. That was on purpose. But even with the weight and like,
Yeah.
it looks so similar, it
Yeah.
can be difficult.
With the URL implicitly as the HTTP transport.
Okay.
And I have this commented out thing here that says with endpoint, net TCP, blah, right?
Okay.
So let's connect via HTTP first to show that it works.
Okay.
So I'm going to connect here. I think this is a client app. No, it's not the client app. Is this a client app?
That's the server.
No, it's a server. Wait, they have to run it twice? Can't. Okay. Let's go to client app and let's run this. And it should be talking over WebSockets from my C# console app.
Okay.
All right. Hey. Oh, good.
Okay.
It's working.
So, okay. You sent hey, you got hey back because it's a chat.
To
right?
prove
Same
it
thing.
that it
Okay.
works, I can open up a browser, which is a fancier app than what we saw before.
Okay.
Aha. Hello, console person.
Okay.
Is up here?
Ah, all right. But that's
Here's the
HTTP
browser.
still. That's just C# at
Right.
this point.
Hey,
All right.
browser guy.
Okay.
Right. Still working. Now I'm going to recompile this app with endpoint, net TCP, localhost 8009.
Okay.
I believe is the port we use to bind TCP to. Let me double check. Yes,
Nice.
it is.
Okay.
Run this again. Now it should be running the same app. So before it printed out this stuff,
Yep.
starting transport, transfer mode, blah, URL, blah.
Yep.
No, it's not saying anything because I didn't add logging. But
You didn't add logging. Okay. Fair enough. That's fine.
so it is TCP, and it still works. So now I have TCP in .NET Client,
And HTTP over here.
HTTP over here, and I can have different transports do the same thing. So I can count down. Actually, this wouldn't work very well, actually.
You're going to count down? Is that going to work?
No, because that's per client. That's not broadcast.
Oh, that's right. That's a return.
So hello, and hello shows up here.
Nice. Okay, so we've got a console app in C# using the SignalR client but connecting via TCP
Correct.
to my ASP.NET Core app, which is running SignalR the traditional way with HTTP, but also taking the same SignalR hubs and binding them directly to Kestrel over
Right.
TCP, and it's all living together in one happy universe.
Yep. And what's interesting is that this is actually using JSON, if you didn't notice before. So JSON is, we're using TCP and JSON on top of that, and then we're
Okay.
using Messagepack in the browser.
We're going to backwards.
Yeah.
We've got JSON on TCP and Messagepack, because why not?
Yeah.
Okay. Awesome. Well, that's really, really cool.
Yeah.
Okay. So that is SignalR over TCP. Now, it is using, you can't do that today out of the box. You have to like steal David's
Copy
code.
my sample. It's a sample in the
sample.
Sigler repository.
So how is this happening? So this is building on top of a new set of primitives that we effectively rewrote Kestrel to support in 2.1. We started in 2.0.
Over 2.0 to 2.1.
We started in 2.0, and then we made we kind of refined it in 2.1 and made it public.
Yep.
And it's called Project Bedrock is the code name. So what is it?
We may get sued. Is that okay to say?
It's a project, not a product.
Okay, good.
So you can call it whatever you like.
Flintstones?
Right? We just can't use it in a name.
Oh, good, good, good.
So project, in quotes, Bedrock. So it's a new high-performance networking abstraction for .NET, okay? Built on everything that we learned about building Kestrel, which I think you know is an incredibly high-performance HTTP server. At least we're trying very hard to make it an incredibly high-performance HTTP server. It is completely agnostic to what the application does versus the transport layer. So we completely separate the idea of an application layer that has its own context types, its own protocols, et cetera, from the actual thing that is transferring bytes from the client to the server, okay? Whether that's TCP, HTTP, or something else. We have existing implementations for transports, as I explained before, using system.NET sockets or libuv, and you could write your own. We have new transports can come online because they're separated and you don't have to rewrite in the app layer. So if we wanted to add support to Kestrel to use Rio. Right? Or registered I/O, which is a Windows-specific, high-performance, low-latency, sort of user mode, memory-managed networking API, we could, and your apps wouldn't change, right? Because the app layer above it doesn't care. Things just get better if you configure that transport to work. It takes the same idea of middleware that we use for HTTP, and it applies it to the idea of connections. So if I have a connection coming in on an IP address and a port, in the case of TCP, or if you're using something else and if you're using NetBIOS, something really old, or I don't know, what else is there? What's a different one that's not TCP IP?
UDP.
UDP, right?
There's one more.
Then you can still create middleware. You get a connection, and then you just want to be able to see the bytes as they come through and do something, or shortcut. You can write middleware the exact same way you do for HTTP. It's just the context you're being flowed is not an HTTP context. It's a connection context, right? And that's called a connection handler. So then you have, this allows us to take ASP.NET Core, all the great things that you know about it, and extend it beyond HTTP. The same app models, the same configuration, the same DI, the same hosting model, the same server, but now you can build server programs that don't just speak HTTP. We also built this on top of the new system.io.pipelines API. So we saw channels, which is a type that lets you push types down it and then get and have them serialized or whatever out the other end. Pipelines is specifically around building, how would you explain it? It's specifically around building things.
And memory management.
Right. It's like streams, but it does all the memory management for you.
Right.
And rather than you saying, here streams, send these bytes, you kind of say, here pipeline, I want you to send this thing and you take care of all the bytes for me. And I want you to call me back if something comes in off the wire. Rather than me having to give you bytes to fill in, you tell me where the bytes are when something comes in off the wire. And why that inversion of that polarity, that's useful because it means we do all the hard work. We manage the threading, we manage the memory management, the pooling, the thread safety, all that stuff is done for you, okay? And obviously this uses a lot of new span stuff under the covers as well, which is, or you can use it in conjunction with the span stuff, so that when you get bytes out of your pipeline, you need to parse your protocol, you can use all the nice low allocating or non-allocating span APIs to do so. And it works on the client and the server, right? Pipelines isn't server only. You can have a client written using pipelines that mirrors what you do on the server, so you get all the same benefits. So what does it look like? So here's the layers here. Server, the server we have that we've written that does this is Kestrel, but you could write your own server that supports the pipelines abstractions. An example of the type of middleware you would have would be TLS. So you take a connection, then you want to encrypt everything over that connection, do a handshake at the beginning, encrypt and decrypt using something like TLS. That's just middleware now, right? It's not a different connection. It's just a middleware that you apply to an existing connection. Or you could log, or you could do something else, right? It doesn't matter. Then you have your app framework, whether it's ASP.NET Core or SignalR Direct, which is what you showed, or something else, maybe a Redis server or whatever you want to do. You write a connection handler, the thing that takes the bytes out of the connection and then does something with them. And then right at the bottom, as we talked about these other transports, sockets, libuv, Rio, and then what on earth is that thing?
So Ben Adams, You know who Ben is, right? Everyone knows Ben Adams by now.
Community member,
Ben Adams, performance guru.
Ben
and
Adams.
Tim Seward, who's been also doing a bunch of performance work in SSL Stream and other various .NET things. We started working on this crazy project like 4 days ago.
Okay.
And it's basically a kernel mode driver for Linux that gives you access to the actual network card in C#. So we're actually writing code to parse TCP IP itself, like in C#. So the code is all in C#. So you end up going from hardware to managed code in one go without any context switching.
You're writing a TCP driver in C#.
There's
that lives in the app.
So the driver exposes the network card to C#, and then we write the networking list on top of that. So normally WinSock, right, is in the kernel or in Linux, and they implement TCP, and the socket API actually abstracts TCP away from you.
I see.
You call read, you call write, and it's done, right? This project is about pushing it further down all into the application, so you have to write the code to parse Ethernet packets yourself.
So you have to be explicit.
You have to be extremely explicit and extremely intentional.
So what is the benefit of doing this? Exactly?
Extreme performance. It is extremely fast.
So the idea, so my guess is that it means, in theory, that you can reduce the amount of time you have to spend going from user mode, like user code, to kernel mode, which Rio does as well.
Correct.
But is fixed for a certain thing, whereas this is a user mode TCP, which we've been hearing a bit about in the community. This is an investigation
it's a
into
trend
what that might
towards,
look like.
It's a total like random side project.
But the point here is that Bedrock supports this type of stuff. It's designed to be flexible all the way down to the craziness that you came up with 4 days ago with Ben and Tim. Okay. Is Quick related to this? QUIC?
Yes.
Okay.
Yes.
So that's another example of a user mode.
Yep.
And so Magma could implement Quick?
Yes, actually, it can.
Okay.
Yeah.
Let's move on. We've got other stuff to talk about. All right. So what's the advantage? So this is a graph that shows the difference between running benchmarks, the tech and power benchmarks that ASP.NET Core has been working very hard to do well in. If we have different implementations. We have ones that use MVC, the full power of MVC. We have ones that use HTTP middleware, so if you just write code in middleware. And now we have a version that just uses Bedrock. Basically, it's just Kestrel. You have Kestrel, you write a connection handler, and then you new up the HTTP parser yourself, parse the HTTP, and you get callbacks when a header appears, and you get callbacks when the start line is seen. Well, what's the performance difference? Well, look at that first graph, requests per second. The top green line is when you use Bedrock, right? Answering basically hello world. It's real, it's not faking it. It's parsing the HTTP and it's returning a new result every time. The middle line is using ASP.NET Core, what you would use today, middleware. And then the red line is using MVC. Okay? So you have a controller with a method and it returns the text hello world. All right? So you can kind of see the steps, what you pay for as you go from one layer to another. And you can see that replicated in all the other graphs. So bottom left is startup time. Bedrock doesn't have to load much. It loads Kestrel, loads your handler, and you're off. So the startup time is very quick. ASP.NET Core has to load a bit more, has to initialize DI, the HTTP middleware, and then MVC obviously has to do a lot more because it has to find your controllers, configure the pipeline for that, et cetera, et cetera. And then latency is interesting. It's a bit of a, we won't get into that. There's reasons why the Bedrock latency is in the middle of the other two, probably because the performance is so much higher. It starts to actually impact the latency. But memory, you can also see the Bedrock memory is lower than the ASP.NET Core memory, which is lower than the MVC memory, right? It's pay as you go. As you add more features and go higher up the stack to get benefits, you pay for more of it in performance. All right. So we're not going to show that.
Yeah, you should get that.
Right, so we built a game to show what it might look like to use Signaler to build something a little more real than chat. So we built Ultimate Tic-Tac-Toe. Right, so we have about, 6 minutes left. So can you show us the game?
Yes. Local or the Azure one?
No, show us the Azure one.
All right, so
we've got it deployed, right? So people could try this now. I'm gonna play you.
The address is ut3.azurewebsites.
ut3 for Ultimate Tic-Tac-Toe.
Can anyone see this? See if it's still working. Still working. Perfect.
Okay.
All right. So
are you going to create a game?
Yep.
Create a game and I'll join it.
Okay.
It's literally called OK. Yep. Okay, so there you go.
Perfect.
So it's your turn.
So wait, explain the rules to the people.
No. So Ultimate Tic-Tac-Toe is effectively Tic-Tac-Toe embedded inside Tic-Tac-Toe.
On steroids.
So every cell is itself its own Tic-Tac-Toe game, right? Now, the key, though, is where he plays in that so there, dictates where I can play. So that gray is saying it's waiting for me. I'm only allowed to play in that cell because he put the X in the top right-hand corner of the first board. Does that make sense? So then I can force him to play in the top left because I put mine in the top left. I put the 0 there, and he can push me to the bottom. He's actually thinking about it because he wants to win. No?
Wait, what happened? Oh.
Did you kill it? Oh, there you go. No? What'd you do?
Oh my gosh, there's a bug somewhere. Someone's trolling.
So I think what happens is because it's, oh, people are playing games, but
God, we should do more testing. So when you select the game, it seems to like.
So when you said
over.
to me,
I know what it is.
When you said to me, it selects the first active game.
Yeah.
Is that the bug?
That's the bug.
Okay. Oh, look, people are chatting. Look at that. Wow. Okay, you should close that very quickly.
God.
So, in the last 4 minutes, what I'd
that.
like you to do is fix that bug. Because it actually turns out it works really well. Like, everyone's on there doing stuff, but they just can't stay in the game that they chose because you keep moving it to a different game. So we'll get that working. One of the traditional things that has been difficult with that, and the code to all this is up on David's GitHub repo, okay? github.com/David Fowl. David Fowl, right? UTT.
It's the wrong number.
UTT, I think it is. So what has traditionally been difficult is when you want to scale this up. You deploy it to Azure, Amazon, wherever you want to go, right? Great. No, Azure. You deploy it to Azure. And then it's like, great, I'm getting lots and lots of people, but I can scale out the web app, but if I scale out the web app to more than one server, all the WebSockets are going to be spread all over the place. So how does Signaler share all the messages across all those servers? So we had this thing called a backplane in the old days. And it was okay, as we mentioned before, but it wasn't particularly good at all workloads. It was really only designed for a single workload type. It probably would have worked okay for this game, maybe, I don't really know. But because you have chat, maybe not, because it's event-driven. So what you really want in the cloud is just a service, right? You just like turn a key and change your app slightly, and then all the Signaler stuff is taken care of for you.
Magic happens.
So that's what the Azure Signaler service is that was announced this week, is now available in public preview. So it is a platform as a service specifically for just terminating the Signaler clients in your application. Your app doesn't run there. Your app runs in a Docker container on AKS, or in IaaS on Azure Web App, Azure App Service, or on a VM that you stand up with behind a scale set in Azure Compute. It runs wherever you want, but the Signaler clients all go to the Azure Signaler service paths that you configured. Okay? It's built on ASP.NET Core Signaler and Bedrock. It's built on all the same stuff that we just showed you. We have been working directly with the Azure team as we build Signaler and Bedrock to make sure that it can work for this stuff. It offloads all the Signaler connections from your app to the service. So you don't have to worry about load balancing WebSocket connections and thinking about how to do that inside your Azure App Service. It goes off to a service that was designed to do it. And then it takes all the traffic and it relays all that back to your app. So your hub is still in your app, but none of the connections are on your app. Isn't that crazy? It's pretty cool. Then you just scale the Signaler service separately to how you scale your app. So you pick the scale that you need for all the HTTP normal traffic, and you pick the scale that you need for the Signaler traffic, and you can do it separately, right? Which is one of the hardest things to solve in the existing Signaler today. And then you can just add more instances if you need to, and it's very, very, very easy to migrate an app to do this. So what does it look like? Once you've deployed, I've got my web application on the left, which is running, say, in Azure App Service, and then it has its hub, its business logic, and that connects over to the server endpoint of the Signaler service. The browser clients, they connect to my web app to get the pages and the CSS and the JavaScript and talk to the MVC controllers, but they connect to the Signaler service to hit the Signaler client endpoints. And then the magic of the Signaler service is that it is sending all that Signaler traffic between the hub in your app and the server endpoint running inside the Signaler service. Okay? And then they take care of scaling everything behind the scenes for you without you having to think about it. It's just one URL for the server to connect to, your app, and another URL for the client browsers to connect to, and then that's it. So to use it, all you really need to do is you get a connection string from the portal, you get your app connects to it, it gets an access token and a URL, You send that down to your clients when they render the page, and then the SignalR client in the JavaScript takes the access token in the URL and uses that to connect to the endpoint of the Azure service, and then it all just magically works together. It even uses part of the protocol that we talked about before, the transport protocol, which enables the server to redirect using that URL there. You can read about that. It's pretty cool. And then this is what it looks like, your app looks like when you do that. You have your in-app over here, and then you can see when you're running on the SignalR service, instead of all the SignalR connections coming through the pipeline, they now come through the WebSocket clients and the Service Hub Dispatcher, which is the service-specific version of all those layers when you're running on SignalR service. All right, we don't have any time to do the demo, which is fine, but you can come to the theater session tomorrow morning if you want to.
Yep.
And these demos are obviously online to do so. So with that, what comes next, just to close out? Coming in future versions, hopefully 2.2. We're going to look at redoing client reconnect so that if you have any trouble with your client connecting or it drops the connection after it starts, you don't have to write that loop yourself. We'll take care of reconnecting for you. We want to add better connection resiliency so the client can send pings to the server. In the case the server doesn't reply, the client can do the right thing. We want to add the ability to do very simple user presence out of the box so that I know that David is connected over these 3 SignalR connections. Oh, but I haven't seen him in 10 minutes. Let me flip a bit that tells me that he's now gone into a different state. And then eventually when all the connections go away, I now know that David is offline. It's quite a lot of code to write today. We'd love to be able to solve that for you out of the box. Extending the idea of typed hubs from the server to the client. So when you're using C# in the client, you can have a type that's the same one as you use on the server to get strongly typed sort of client-to-server SignalR hub messages. That would be nice. We need to write more clients. We have TypeScript and C# today. We plan to do Java and C++ next. And we have a lot of people asking for a native iOS client, so we're going to look at that as well. And then, as we showed you, extending beyond HTTP to things like TCP, which is just a sample today. We need to make that more real. So please try it out and give us feedback. It is available in the release candidate now. If you have any issues, please go ahead and log them up on GitHub, and we'll do our best to fix them as quick as we can or to help you out. But other than that, thank you very much for coming. Enjoy the rest of build. Go to David's GitHub to get the samples, and we'll see you next time.